In this flip, we will discuss the concept of Ka, the acid dissociation equilibrium constant, which is the measurement of the strain of the acid. As a quick review, in general chemistry, you discussed two types of acid-base concepts. One was Arrhenius acid-base, where a substance that dissociates in water produces hydrogen ions. And second was Brownstein-Lowry acid, where Brownstein-Lowry acid definition is that the substance that can transfer hydrogen ions, for H+. In other words, a proton donor. We called conjugate acid-base pairs a chemical species whose formula differ only by one hydrogen ion. For the definition of acid strain, we are going to use combination of two definitions of acid. The first one is the Arrhenius definition. An acid is a compound that lowers the pH of water. The second method by which the acid lowers the pH of water. This happens by increasing the concentration of hydronium ion, H3O+. For example, in this slide, strong acid, HA, dissociates into H3O+ and A-. For a strong acid, the extent of dissociation is nearly 100. In general chemistry course, you were asked to memorize strong acids. Review them. The rest of the acids are weak acids or very weak acids. Weak acid, for example, HA, will have a partial dissociation into H3O+ and A-, thus creating an equilibrium where the extent of dissociation is considerably less than 100%. We use the expression Ka to define the equilibrium constant, which will be a Kc basically value for the Brownstein-Lowry reaction of an acid with water. For any acid, HA is in equilibrium. HA plus water goes to A-, the conjugate base of an acid, plus a hydronium ion. Remember this reaction. This means that Ka is equal to the concentration of A- multiplied by the concentration of H3O+ over the concentration of HA. The strain of an acid is related to its Ka value. The stronger the acid, the higher the Ka. The weaker the acid, the lower the Ka. Polyprotic acids can have multiple Ka values. Ka refers to the single Brownstein-Lowry reaction. So for example, the Ka1 for the carbonic acid refers to just the first proton being transferred, while Ka2 will be for the second. In this flip, we'll learn how to write the Ka for the reaction and equilibrium constant expression for any acid and use Ka to relate strain of an acid.